So today we are going to be looking at word problems with systems of equations. I guess good, bad news, however you want to look at it, is really we're just pulling from the exact same skills that we learned earlier this trimester. So when we are looking at these word problems, since we're now dealing with a system, we're going to have two equations that we get instead of just one. Okay, which means each equation is going to have two variables. You can pick whatever two variables you want. I do think just in terms of solving for systems, unless it's a real true story problem where it might be easier to assign us a label with a letter, to sort of stick with X and Y. But the key is that we want to use those exact same rules we learned earlier in the trimester. So I linked these on the Canvas homepage. But if you open up the link on Canvas homepage, this is that document that we used, however many weeks ago it's been now, that you can sort of go through and remember all those key terms. Now, my hope is obviously that we can use this list less and less. But I still want to point this one out because we still haven't been successful in just across the board always getting this right. The reminder that less than and subtracted from tell us to change the order. So if we read something like 11 less than a number, okay, 11 is first, a number is second, but because we read less than, when we write that down, we're switching the order, right? And the 11 is coming last and a number is coming first. So we just really want to make sure we're keeping that in mind. That hasn't changed. It's been that way all year, but just so that we don't forget that. Okay, so if we go back to this document, you can use any way that you want to solve. So whether you choose to solve by graphing, substitution, or elimination, that's sort of going to be your preference. I tend not to solve by graphing unless I actually have a graph. So I don't do that all that often. But maybe if you have some graphs still left over and you want to use that, you could consider that. Substitution is usually the best option to pick if we read something that says X equals or Y equals. And elimination is usually our best option to pick if we have that sort of X stacked on top of an X, Y on top of a Y, right? Equals on top of an equals sort of format. Everything else is going to be going along with the exact same rules that we have been doing. So let us take a look at this. Number 1 says, find two numbers whose sum. Okay, so we're looking for two numbers whose sum is 7 and whose difference is -3. And then we want to find the numbers. Okay, so what is this problem asking us to find? It's asking us to find two numbers. So we need a number 1 and we need a number 2. And we can label those with whatever letters we want, but I am going to label those with an X and a Y. Okay, whose sum? So when I add up these two numbers, because sum tells us to add, is tells us equals 7. Okay, and is sort of like one of those words, right, where we take two sentences and we put them together. Math is very similar to English in that language structure. When we start a new sentence, we want to start a new equation. So because we're connected with that word and, right, it's like an entire other sentence that's just been connected with it. So, and whose difference? What does difference tell us to do? Difference is subtraction. So we're going to use a minus sign, same numbers, is -3. Now, these problems are all nice and neatly stacked. That doesn't mean that you have to choose elimination, but this is nice and neatly set up for elimination. So if we decide we want to solve this by elimination, we want to find which variable has the same matching number sitting in front of it. And in this problem, the X's and the Y's both have the same number sitting in front. But there's going to be one that's a little bit easier to do. And my suggestion is that you pick the Y's because the Y's already have the opposite sign. Oops, I clicked something I didn't want to click there. Sorry, let me take this off. Okay, so if we focus on these Y's already have the opposite sign, which means the opposite sign tells us to either add or subtract. What do we want to do when they have the opposite sign? We want to add. So we're going to take these two equations and we're going to add straight down. So x plus x gives us 2x. The y's cancel. 7 plus -3 gives us 4. And this is something we can then solve. So now we have x equals 2. Now, we're not finished because we still need to find our y value. So what do we want to do to find our y value? We need to plug that back into one of these. I'm going to plug it back into the top one just because it didn't have any negatives. So x is now 2. So I'll say 2 plus y equals 7. So we will say y equals 5. Now, in the past, we've always sort of wrapped this up by saying, okay, this gives me an ordered pair 2, 5. But this problem really isn't asking us to solve a system. We decided to use a system to solve it because it maybe helped us find a method that was easier than just guessing some numbers until we found the right one. But we could just guess 2 numbers until we found the right one. Okay, there are other approaches we could use, which means we don't want to write our answer to this as an ordered pair. Okay, it asks us to find 2 numbers. What are 2 numbers that have a sum of 7 and who have a difference of -3? Well, those 2 numbers are 2 and 5. Okay, so our answer is just 2 and 5. Okay, so now let's take a look at another one. Okay, so up here we have 3 times one number added to another number is 10. Then we have 3 times the first number minus 2 times the other number is 16. So we have one number and we have another number. This is just saying those are x and y's. Those are 2 unknowns. We just want to make sure that our first number, right, the first number that we pick is going to be our x, and the second number that we pick is going to be our y. So how would we write 3 times one number? We would write 3x added to another number, so plus another number, which is y, is 10. So again, new sentence means a new equation. So now we have 3 times the first number. The first number doesn't mean any number that we wrote down before. It's just saying pick that same variable that we picked for the first number in the first sentence. So the first variable that we picked was x. So again, this says 3 times the first number. So this is going to be 3x. If I can get it together here. Minus, how would we write 2 times the other number? We should write 2y equals is 16. Now again, we could choose to solve this by graphing, substitution, or elimination, but we have this nice, neat stacked pattern going on. So elimination is kind of what makes sense here. So if we choose elimination, which variable do we see that has a matching coefficient? Right, our x here has that matching coefficient happening. Now, we could multiply and do something with the y's if we wanted. There's nothing that says we can't do that. But I'm doing this before some of you know how to multiply. So some of you are going to be waiting to learn that later. So we're going to stick to the elimination here. Okay, so that top 3 is positive and that bottom 3 is positive. So when they were both the same sign, what should we pick? We should pick subtraction. So we also said when we're subtracting, we don't really want to subtract. What do we want to do instead? We want to add and then distribute a -1 or change the sign of everything following it. So that +3 is becoming a negative, the -2 is becoming a positive, and the +16 is becoming a negative. And so now we are going to add straight down. So the x's cancel. 2y and a y gives me a 3y. And a -6, and this is something that we can solve. But just like before, right, we're not done because we need the x and the y. So we're going to plug this back into one of them. I'm going to pick the top one. So now I have 3x plus -2 or -2 equals 10. 3x equals 12. So x equals 4. Just like the last problem, right? We were really just looking for two numbers, so our answer is going to be 4 and -2. Okay, one last problem here we're going to look at. 3 times one number equals twice a second number, and twice the first number is 3 more than the second number. Find the numbers. What is the equation that we are going to want to write to represent this first sentence? We should have picked, right, 3 times one number equals twice a second number. So we should have picked 3x equals 2y. What is the equation we are going to want to use to represent this second sentence? Okay, we have twice the first number is, so equals, 3 more than tells us to add the second number. So 2x equals 3 plus y. We also could have put that down as 2x equals y plus 3. Those are the same thing. So now we don't really have this nice, neat, stacked look going on, which means elimination probably isn't the option we want to go with here. So here we probably want to go with the option of substitution. So in substitution, we want to find a variable that doesn't have a number sitting in front of it. So what variable are we going to want to pick here? We want our y in the second equation, but this does not have y by itself, and we need it to be y equals, which means we need to move this 3 over and get a new equation that's equivalent, right? It's the same, but it looks different. So I no longer want this. But now I can circle my y and underline what it equals of 2x minus 3. So because I circled my y, what letter am I going to cross out in the first equation? We should be crossing out the y. And what are we going to put in its place? We should be putting in 2x minus 3. Now that's multiplication, so parentheses. So we'll have 3x equals 2 times 2x minus 3. Okay, so I want you to solve this and tell me what answer you get for x. So when we solve this, we should have distributed. That should be a 4. Sorry, I can't. Then we're going to solve. Now, if I'm solving this, I could subtract the 3x or the 4x. Typically, my students subtract the 3x because it's smaller, but I don't want an empty aside. If I subtract that 3x, I have nothing left over there. So I'm going to move my 4x. And so we get x equals 6. Okay, but we're not finished. We still need to find the y. So I want you to decide where to plug that back in and tell me what you get for y. So I would have plugged this in over here where we underlined and said 2 times 6 minus 3, which is 12 minus 3 or 9. So we get y equals 9. But again, this is just a word problem to start with. So our final answer will be 6 and 9.